Okay, here's kind of a challenging problem, I guess. But the problem is this. Liquid octane will react with oxygen to produce carbon dioxide and water. And so suppose 42 grams of octane is mixed with 94.7 grams of oxygen. Calculate the minimum mass of octane that could be left over by the chemical reaction. Okay, so we're calculating it's going to be left over, so we're going to be dealing with the reactants often through here. But there is maybe a little strategy to these, and let's work our way through this problem. Okay, first thing to do is get that chemistry right, and so I'll write the chemistry up here. And so we have octane, which is C8H18, just I rewrote that in a more legible form. Plus oxygen, it's a combustion reaction, is going to yield us CO2 plus water. So this is like gas in your gas tank in your car burning. And so when we balance these here, let me give me a little more room right there. So when we balance these here, then we're going to get 2 here, we're going to get 25 here. For the CO2, we're going to get 16, and for the water, we're going to get 18. So that is a balanced equation right there. Okay, so now that we have the balanced equation, step number 1 that I would say in our little algorithm here is to find starting moles and then save them some way. So find the starting moles. Okay, and so here we have 42 grams, so we have 42 grams of octane, C8H18, and over here then we're going to have 94.7 grams of oxygen. Okay, so when we convert these into moles, then I know that there's 114.142 grams in 1 mole of the octane, C8H18, and I know that there are 32 grams in 1 mole of oxygen. So when I do that math, then I get, this is 0.36799, give me a few digits out there, and this is going to be 2.9593. Okay, so I have moles now of each one of those. Now, the second thing that we want to do in this step is to find the limiting reactant. So find the limiting reactant. Okay, so which one's going to be used up first? It's asking us to calculate the mass of octane that could be left over. Well, if it's the limiting reactant, it's going to be 0. It's going to be all consumed, and so we need to know that. So this is in moles of C8H18, and so let's just choose one of these, and I'm going to choose carbon dioxide. So I know that for every 2 moles, of octane, I'm going to generate 16 moles of CO2. And for the oxygen, this is moles of oxygen, for every 25 moles of oxygen, then I'm going to generate 16 moles of CO2. Okay, so this will tell me what my limiting reactant is when I do this math. Whichever one gives me the fewest number of moles, then that's going to be the limiting reactant. And so when I do these calculations, I get 2.9439, and for this bottom one I get 1.893. Okay, so in this case my oxygen is going to be my limiting reactant. That's all going to be consumed, and I am going to have leftover octane. And the question is, how much leftover octane do we have? Okay, so we have to just do the stoichiometry. We have to do the little chemistry that's going on here. And so I'm going to, since oxygen is the limiting reactant, I'm just going to start off with the number of moles of oxygen that I started off with, which is this number right here. Remember, we calculated that. So if I start off with 2.9593 moles of oxygen, then I want to find out how many moles of the octane I'm going to consume. And so I know that for every 25 moles of oxygen, I'm going to consume 2 moles of C8H18. And I can actually take that further. Those are moles. I can take that one step further and calculate the number of grams that are going to be consumed. Because I know that in 1 mole of octane, there are 114.142 grams. Okay, so when I do that math, this is going to tell me, and that's grams of octane, it's going to tell me how many grams of octane, 8H18, that I have consumed. All right, so when I do that math, I get 27.0, still have it on my calculator, 27.0224, something like that. That's how much I've consumed. Well, how much did I start off with? I started off with 42 grams, and if I subtract how much I consumed, okay, that's going to give me, and when I count my sig figs right here, then that's going to give me actually about 15. The answer to this one with the right number of sig figs is going to be 15 grams. Okay, so what's the strategy here? Again, this is how I do it. You find the starting moles. That's number 1. Find the starting number of moles, and then do the stoichiometry to figure out which is your limiting reactant. We did that here, and we found that here are the molar amounts, and oxygen gave me the fewer molar amount, so that's the limiting reactant. Okay, now that I know that's the limiting reactant, I can actually start with that knowing it's going to be consumed. So I started with those number of moles, moved that right down here, and I just did this stoichiometry between the oxygen and the octane. And I said that for every 25 moles of oxygen, then I'm going to consume 2 moles of the octane, and then I went right into grams. I just continued that reaction using my dimensional analysis, going out to grams. This gave me the grams of octane that I consumed. All right, so I can take the amount I consumed, subtract that from the amount I started off with, and that will give me my answer. That's the strategy that I use to get these. These are doable. Just get a little strategy in your head for how you're going to do it, and I think we can solve these problems.